Welcome to the QuickStart guide for GPI, the Graphical Programming Interface. I'm Nick Zwart, and I'll be showing you some of the basics of GPI. This QuickStart guide will cover how to launch GPI in each platform, and then spend most of the time looking into the most pertinent elements of the user interface. I'll then show you where to find packaged examples to start your own exploration. Before we start, you need to have downloaded and installed a copy of GPI from gpilab.com. You will also need a 3-button mouse with a scroll wheel. The platform-independent way to start GPI is from the terminal. This requires a proper setup of the user environment as detailed in the installation instructions. So regardless of the platform you are using, open a terminal window and type GPI at the prompt. When you press return, the GPI canvas will pop up and be ready for editing. If you already have a network file, you can type GPI followed by the path of the network file, and GPI will start with the target network. Installations on OS X also install a startup script in the Applications folder. This can be found by opening a Finder window, navigating to the Applications folder, and then double-clicking on the GPI icon. You can also drag the icon into the dock for easy access. Similarly, in the Linux virtual machines, there is a pre-installed GPI launcher in the dock, which just requires a single click. Now we're going to cover the user interface, and we're going to start with nodes. To instantiate a node from the mouse menu, right-click on the canvas and drill down into the core library. I'm going to start by getting a shapes node, which is in the core generators library. Left-click on the node of interest, and the node will appear on the canvas. You can search for nodes from the mouse menu search bar at the top. Just start typing the name of the node, and the search results appear as a new menu. You can also pull node code files in from the browser. To select multiple nodes, left-click and drag over the nodes you're interested in. The red border around each node signifies that it is selected. Then to delete, just press the delete or backspace button on your keyboard. Connecting and disconnecting nodes. To make a connection, hover over a port to make it larger. Then middle-click and hold. Notice that when you middle-click a port, there are other ports that also get bigger. This indicates that those ports are the same data type and are therefore connection candidates. Continue to hold the middle button and drag towards the port you wish to connect. You'll see that the mouse cursor will change to a cross-out symbol if a connection cannot be made, and a plus sign if the connection can be. When you see the plus sign, you can release the button to complete the connection. As soon as the connection is made, the downstream node will execute. To disconnect, hover over the connecting edge. The edge will turn red to indicate it's being hovered. Right-click the edge to pop up the delete menu and click delete. The node menu. Right-clicking on any node will open its node menu. This is where the node's algorithm is parameterized via the widgets contained in the menu. You can see that there are push-button widgets, multiple choice widgets, sliders, and type-in-value widgets. In this case, the widgets are used to parameterize a window function for a 1, 2, or 3-dimensional array. As each widget is modified, the node is run to recalculate based on the new parameter changes. Towards the bottom of the menu, there are 2 widgets which accompany all node menus. They are the node label and about widgets, and they are both collapsed by default. To expand the node label, double-click the widget area. The node label is a text string which can be used to append a descriptive title to the node name shown on the canvas. The About widget contains a brief summary of the node's operation and parameterization, which is taken directly from the node description code. And now the canvas. The canvas can be zoomed out and in with the mouse scroll wheel. To pan the canvas left, right, up, or down, middle-click, hold, and drag. This is equivalent to using the scroll bars located on the right and bottom of the canvas. To add another canvas tab, click the plus button located in the upper right of the canvas. You can copy node configurations between canvases by selecting the nodes of interest and either using the copy-paste functions from the mouse menu or using the standard keyboard shortcuts. In some cases, we want to parameterize or make a few node connections before allowing each node to recalculate. To do this, we can pause the canvas via the mouse menu or keyboard shortcut. The yellow color marks the pause state. In this case, a few parameters have been changed in the Shapes node, and Shapes has been connected to Statistics. When the canvas is unpaused, this network will execute. Getting runtime feedback. The most used information comes from the port tooltips and node tooltips, which can be accessed by simply hovering over the ports or nodes. Before hovering, first make sure the canvas is in focus by clicking on it. The port tips show the port names and data specifications. The node tips show the execution time and amount of memory held at the out port. This spiral chords node, which generates spiral k-space coordinates, has two green input ports. The green indicates that they are optional and not necessary to generate coordinates. The output ports are red, indicating that they are not holding any coordinate data or gradient waveform data yet. The Statistics node has one blue input port. The blue indicates that the data is required at this port in order for statistics to be calculated. The four output ports of the Statistics node are also red, indicating that no statistics have been calculated. This network requires the spiral chords node to be correctly parameterized before any nodes will execute. This is done by simply raising the spiral chords node menu and clicking the button labeled Compute. Now when we examine the output ports of the Statistics node, we see that each one has been calculated. If we go back to the node menu and toggle the Compute button off, the output ports of the spiral chords node are now yellow, indicating there has been no change. Since the data at these ports have not changed, there is no event to trigger further downstream node execution. Node warnings and errors occur when the node is not correctly parameterized, or often during the development of a new node. In this case, my node is being developed to read a new file format. It is designed to give the user a warning, signified by a yellow node color, when the user enters an invalid file name. To clear the warning, the file name parameter is set to a valid value, and the canvas is paused and unpaused to clear the warning. In this example, the myFile file extension is valid. However, its implementation is not yet complete, and so the underlying code has crashed, causing the node to fall into an error state, indicated by the red color. And the canvas has automatically changed to a pause state. The error state gives the developer an opportunity to fix and retest the code. Now that the code is fixed, the node can be copied and pasted, which loads the new code. The erroneous node can be deleted, and when the canvas is unpaused, the new node runs. There are very few dialog boxes in GPI. Most of the textual error feedback is produced on the terminal that is used to launch GPI. The terminal is also the place to go to find the output of print or logger statements. Both the native GPI installers and the virtual machines contain example networks and data. These examples can be found by navigating to the Help menu from the main menu bar and selecting Documentation. This opens a directory containing document files for QuickStart and node development. From here, you can open the Examples folder and simply drag and drop an example network onto the canvas. You should now have a basic understanding of how the interface works and some examples to explore. The next screencast will cover typical use cases and algorithm construction in the form of network exercises. You can find more information by visiting gpilab.com.